Hello dear students, welcome to the series of NEET Crash Course Physics. In the first lecture, we have completed the chapter Algebra of Basic Maths. In this lecture, we will cover the chapter Trigonometry. So let us start with the trigonometry. So trigonometry is nothing but that branch of mathematics that gives relation between sides and angles of any triangle. So this is the definition of trigonometry. So before proceeding further, let us first define what is angle. So suppose for defining angle, if I construct a circle and here this purple line is the reference line. What is the need of reference line? Whatever angle we measure is measured with respect to this reference line. Suppose I draw another line with this green color. So if this green line coincides with the reference line, then the angle made is 0. Now as I rotate this green line, its inclination with the reference line increases, and angle here the angle becomes 90 degree, here the angle becomes 180 degree, here 270 degree, and if I rotate this in a complete circle, then the angle made is 360 degree. So how can we measure angle? Suppose I stop this line here. So the angle formed here, this angle formed here, this is known as theta, and this is taken in anti-clockwise sense, counterclockwise sense. So since this is taken in anti-clockwise sense, this angle theta is taken as positive, isn't it? Suppose I make another line with yellow color. Now the angle made here, let us name that angle as alpha. So this angle alpha is taken in clockwise direction, so it will be taken as positive. So what is the sign convention for angle in trigonometry? If you take angle with respect to reference line in anti-clockwise sense, then it will be positive, otherwise it will be positive, and if you take angle in clockwise sense, then it will be negative. Now how can we define this angle theta? So it will be defined in the way that this is arc, and let us suppose the length of this arc is theta. So how this arc is formed? This arc is formed by the help of two lines. The first line is reference line, and the second line is this green line, whose angle is to be measured with respect to this reference line. So this is arc L, and the radius of this circle is r. So theta is defined as arc length divided by radius, that is theta is equal to L by r. So this is the formula of theta, and SI unit of this theta is radian. SI unit is radian, represented by RAD. Another unit of theta is degree. In terms of degree, we also measure, and we will have look at the relation between the radian and degree. So suppose here again I am constructing a reference line. Now this is reference line, this purple line is reference line, and I have to measure angle of this green line. So here it makes 90 degree, here it makes 180 degree, isn't it? So we all know that here the angle made is, this angle is in terms of degree, this is 180 degree, isn't it? Now if I put this formula, or you can say if I use this formula, theta is equal to L by r. So in this case, if we apply this formula, then length of the arc will become the length of this semicircle, because the arc covered by these two lines, that is this reference line and this green line, forming a semicircle. So the length of arc becomes half of the circumference of the circle, and radius is r. So in this case, theta is defined as, suppose this is alpha, that is 180 degrees. So in this case, alpha is defined as length of arc by radius, the same formula. And here we are getting alpha in radian, because we are using the formula that is L by r, and from this formula we get the value of theta in terms of radian. So this alpha is equal to L by R is equal to 180 degree. Now this L is half of the circumference, so circumference. The circumference is 2 pi r, its half is given as pi r divided by r, and this comes in radian is equal to 180 degree. Solving further, this r gets cancelled. So we have the relation pi radian is equal to 180 degree. This is very important. Pi radian is equal to 180 degree. Now with the use of this basic formula or this basic conversion formula, we can find different values in terms of angle. I mean in terms of degree and radian. Suppose if I divide this equation by 2, then pi by 2 radian is equal to 180 by 2, that is 90 degree. Suppose if I divide it by 3, then pi by 3 radian is equal to 180 by 3 is 60 degree. Suppose I divide it by 4, then pi by 4, that is 180 degree by 4. This is given by, that is 45 degree. In this way, suppose if I write 3 pi by 2 radian, 3 pi by 2 radian, then this will be equal to, multiply this equation by 3, 3 pi by 2 is 90 into 3, that is 270 degree. Multiply this equation by 2, you will get a different relation, 2 pi by 3 radian is equal to 60 into 2, that is 120 degree. So in this way, you don't need to remember all the angles. Hai. This is the very basic formula of conversion factor. Pi radian is equal to 180 degree, and with the use of this you can find all other values. Okay. On further solving, you will have the value like 1 degree, or you can say 1 radian is equal to, nearly equal to 57.3 degree, and 1 degree is equal to 1.714 into 10 to the power minus 2 radian. So this is the direct formula, isn't it? So that's all for angle. Now let us switch to the next topic. Now trigonometric ratios. In trigonometry, suppose this is a triangle, and here let us suppose this is angle theta. This side is P, this side is B, and this is H. This is 90 degree. Side opposite to right angle is hypotenuse. This can be said as perpendicular, that is side opposite to angle theta. And this is base, that is side adjacent to angle theta. Now there are 6 trigonometric ratios. There are 6 trigonometric ratios. The first one is sine theta. So sine theta is given by and side opposite to angle theta, that is opposite side by hypotenuse. Opposite side by hypotenuse. So this is P by H. Cos theta is adjacent side by hypotenuse. Adjacent side. So adjacent side to angle theta is base, and this is H. So this is B by H. Third one is tan theta. Tan theta is opposite side by adjacent side, that is P by B. Now, there are 3 trigonometric ratios, sine theta, cos theta, tan theta, that you already learned in class 10, and their inverse, that is 1 by sine theta is cosec theta. So what is cosec theta? That is 1 by sine theta. Sine theta is P by H, then cosec theta will be H by P. So in physics, we have to, bother about only these 3 ratios. These are rarely used. Cosec theta, sec theta, and cot theta are rarely used. Most commonly used are these 3 trigonometric ratios, that is sine theta, cos theta, and tan theta. And this trigonometry chapter has got a very important role in chapters like alternating current of chapter class 12, electromagnetic waves, that is the last chapter of first part of class 12, and in 11, that is the last 2 chapters, that is oscillation and waves. So we represent this oscillatory motion or simple harmonic motion, or the wave nature of any sound like sinusoidal wave. Simple harmonic motion is represented by a sinusoidal graph, that is nothing but the sine curve and the cos curve, isn't it? So this trigonometry has got very important role in these chapters. So cosec theta is 1 by sine theta, sec theta is 1 by cos theta, and cot theta is 1 by tan theta. So there are 6 trigonometric ratios. Also, the tan theta is given by, this is very important, tan theta is given by sin theta by cos theta. Now, next is sign convention. This is very important, sign convention. Now, these are the coordinate axis. Coordinate axis. So this is positive x-axis. This is negative x-axis. This is positive y-axis. And this is negative y-axis. Here it is the origin. Now, this is known as first quadrant. This is known as second quadrant. Quadrant means 1/4 portion, isn't it? So this is the first quadrant, that is the 1/4 portion of this whole graph. This is the second quadrant. This is the third quadrant, and this is fourth quadrant. Now, what is the features of this quadrant? The features of this quadrant are, in the first quadrant, theta is greater than 0 degree but less than 90 degree. Suppose you construct any line here, any line. So the angle made by this line with this reference line, this is known as reference line. Hai? So whatever angle we measure, it will be always from this positive x-axis, and this positive x-axis is reference line. So this angle, first of all, we have taken in the sense anti-clockwise manner. We take this angle in the sense anti-clockwise manner. So this angle will be positive definitely. And if this line is in the first quadrant, that this angle theta will be greater than 0 degree but less than 90 degree. If it exceeds 90 degree, then this line will reaches the second quadrant. And in second quadrant, the angle theta is greater than 90 degree but less than 180 degree. Now, if it exceeds this second quadrant, then it reaches the third quadrant, and in third quadrant, the angle theta is greater than 180 degree but less than 270 degree. And in the fourth quadrant, the theta is greater than 270 degree but less than 360 degree. So these are the values of theta in first, second, third, and fourth quadrant. Now, what is sign convention? This is very important topic, that if you are in first quadrant, then all trigonometric ratios, that is, we have 6 trigonometric ratios: sine, cos, tan, cot, sec, cosec. All trigonometric ratios will have positive value. Suppose you are taking that sine 35 degree. So sine 35 will be positive because 35 angle is 35. It means it is in the first quadrant. So it will be positive. Cos 35 can tan 35, cot 35, cosec 35, sec 35. All trigonometric ratios will be positive. But in second quadrant, sine theta and its inverse, that is cosec theta. Only sine theta and cosec theta will be positive, and rest all the trigonometric ratios are negative. Suppose if theta is 135 degree. So theta is 135 degree, it means that its value is greater than 90 degree but less than 180 degree. It means that you are in second quadrant. So in second quadrant, sine theta will be positive. It means that sine 135 degree or cosec 135 degree, they have positive values. But cos 135 degree, tan 135, cot 135, cosec 135, all will be negative. In the third quadrant, T for third, T for tan theta and its inverse, that is cot theta, they have positive values, and rest all the 4 trigonometric ratios are negative. And in fourth quadrant, that is cos theta and its inverse sec theta are having positive values. So you must remember that rhyme given in the R.D. Sharma book class 10, all school to college. All school to college. It means that in the first quadrant, all trigonometric ratios are positive. In the second quadrant, as for sine and its inverse, sine and cosec are positive. In the third quadrant, tan and cot are positive. And in the fourth quadrant, C for cos and sec are positive. So in this way, you can learn these values, isn't it? Now the next part is, so this is the sign convention. Now next, now we have, there are some standard values, and in examination, if your solution comes across this standard values, then the examiner expects that you must know these values, isn't it? So the we have different values. For example, if you say sine 0, so sine 0 is 0, sine 30 is 1 by 2, that is 0.5, sine 45 is 1 by root 2, 1 by root 2 is 0.707, sine 60 is root 3 by 2, that is 0.866, sine 90 is 1, isn't it? Now here cos 0 is 1. Now write this value of cos theta in reverse order. Here it comes 1, then root 3 by 2, so here its value is root 3 by 2, then comes 1 by root 2, this is 1 by root 2, then 1 by 2, and finally cos 90 is 0. So tan theta, sin theta by cos theta is tan theta, so 0 by 1, 0. This will be tan 30 is 1 by root 3, tan 45 is 1, tan 60 is root 3, and tan 90 is 1 by 0, or in physics we can take it as infinity, isn't it? So these are the standard values: 0, 30, 45, 60 and 90. There are two more standard values which we see further. Now sine 120, 135, 150 and 180. Now write these values in reverse order. Suppose here it is 1, then before 1 it is root 3 by 2, then after 1 again put root 3 by 2. So sine 120 is root 3 by 2. Here before root 3 by 2 is 1 by root 2, so after root 3 by 2 is 1 by root 2. Before 1 by root 2, 1 by 2, this is 1 by 2, and finally sine 180 is 0. Here before 0 is 1 by 2, so after 0, that is cos 120 is 1 by 2, 1 by root 2, 1 by root 2, root 3 by 2, root 3 by 2, and here it is 1, 1. But one thing please keep in mind, dear students, that if I write sine 120, so sine 120 means the angle 120 lies in the second quadrant, and in second quadrant sine theta will be positive, no doubt. But if you talk about cos theta, then this cos theta is having positive values in the fourth quadrant and first quadrant. But here cos 120 if I write, then this 120 lies in the second quadrant, and in second quadrant cos theta is having negative value. So all values come with negative sign. Are you getting now? Because it is cos. In the same way, write in reverse order, that is root 3 minus 1 minus 1 by root 3, and here it is 0. But again, in since this is this theta 120, 135, 145, these are theta belongs to second quadrant, and in second quadrant the value of tan is negative, so put negative sign in here. So these are some standard values, isn't it? Now if you want, then you can have a screenshot. Now triplet, what happens, there is a special triangle, and there are questions which are based on this Pythagorean triplet, which are asked many times in NEET in the chapter corresponding to vector, motion in straight line, and all that chapters, isn't it? Suppose here we have, this is side having 4 meter length, this is 3 meter length, then this is Pythagorean triplet, that is 3, 4, 5. Now let us suppose this is angle alpha and this is angle beta. So this Pythagorean triplet 3, 4, 5. Do you know the Pythagoras theorem? Now 3 square plus 4 square is equal to 5 square. So this is a one of the kind of the right angle triangle. So here the side opposite to, I mean the angle opposite to side 4 meter. So this angle alpha is equal to 53 degree, and the angle opposite to side length 3, this angle is equal to 37 degree. So this is very important, na? So 3 by 4, 3, 4, 5 corresponds to two angles, that is 37 degree and 53 degree. And remember the theorem of maths that angle opposite to greater side or bigger side is bigger. So here angle alpha opposite to 4 will be 53 degree. So out of 53 degree and 37 degree, how can you decide which one is 53 and which one is 37 degree? Very simple. The angle opposite to greater side, out of 4 and 3, which one is greater? 4 is greater. So the angle opposite to this 4 is 53 degree, that will be bigger, and angle opposite to this 3 is 37 degree. Okay, so angle opposite to smaller side is smaller, angle opposite to bigger side is bigger. So this is one of the triplet. So here we can find the relation. For example, if I write sine 37, Hana? So what is sine 37? Observe, this is 37 and this is 37. So opposite side by hypotenuse. So this is 3 by 5 and this is equal to cos 53. Because cos 53 is given by adjacent side by hypotenuse, that is 3 by 5. Hana? Then if I write sine 53 is equal to 4 by 5. So this will be cos 37. Acha, follow, listen, observe the pattern of the sine and cos. What happens if angle increases, the value of sine theta increases. As the angle theta approaches from 0 to 90 degree, the value of sine theta approaches from 0 to 1. That is in increasing manner. But in case of cos theta, when angle increases, the value of cos theta decreases. Angle increases from 0 to 90 degree, but cos theta decreases from 1 to 0. That's why here the angle is less, sine 37, the value is less, 3 by 5. But the angle corresponds to cos is greater, that is 53. Anna, always remember na, the value of cos 53 must be less than value of cos 37. That's why cos 53 is 3 by 5 and cos 37 is 4 by 5. But out of 3 by 5 and 4 by 5, 4 by 5 corresponds to sine 53 and 3 by 5 corresponds to sine 37, because as angle increases, the value of sine also increases. That's why when angle is increased from 37 to 53 degree, the value of sine theta increases from 3 by 5 to 4 by 5. However, the value of cos theta decreases from 4 by 5 to 3 by 5 when angle increases from 37 to 53 degree. So you must remember the things by following some logic, isn't it? There must be some logic. So these are the triplets. Now there can be many more triplets if you multiply this value by any number. For example, this is 3, 4, 5, one of the triplet. Multiply these numbers by 2, then 3 2s are 6, 4 2s are 8, 5 2s are 10. So this is one of the triplets. 6 square plus 8 square is equal to 10 square. Again, since the ratio of the sides are same, so the angle when you form this, when you form the right angle triangle using these side lengths, then also the angle will remain same, that is 37 degree and 53 degree. If you multiply this by 3, so 3 3s are 9, 4 3s are 12 and 5 3s are 15. Again you form a triangle by using these sides, then you have the angles 53 degree, 37 degree and 90 degree. So are you getting? So in this way you can form many triplets. Now out of this category, one more triplet is 5, 12, 13. 5 square plus 12 square is equal to 13 square. Now again you have many triplets based on this triplet by multiplying these numbers by 2, 3 and so on, so on, so on. Isn't it? So this is important, no? In vectors, you come across such kind of questions where you have to use this triplet, that is 3, 4, 5. So triplet is over. Now dear students, here we have some formula. There are many formulae in trigonometry, but we have to keep in mind only those formulae which are useful in physics. So, I am writing the formula. So the very first formula is, and whatever formula we are writing, we are looking here, this formula you must keep in mind. So you come across this formula in chapters oscillation waves, in 12th electromagnetic waves, alternating current in these chapters. So the formula. So the first formula is sine of minus theta is minus sine theta. Cos of minus theta is equal to cos theta. For example, cos of minus 30 is equal to cos of 30. Both have the same values. Hai na? But sine of minus 30 is minus of sine 30. For example, sine 30 is minus 1 by 2, but sine of minus 30 is minus 1 by 2. But in the case of cos theta, cos of minus 30 is root 3 by 2 and cos of plus 30 is also root 3 by 2. Both have the same values. Tan of minus theta is minus of tan theta. Next very important formula, sine 90 minus theta is equal to cos theta, and cos 90 minus theta is equal to sine theta. For example, sine 30 is equal to cos, this is sine theta is equal to cos 90 minus theta, that is 90 minus 30 is equal to cos 60. Both have same value. Sine 30 is also 1 by 2, cos 60 is also 1 by 2. So I am just giving you the demo of this formula. So cos 90 minus theta is sine theta. Sine 90 plus theta is equal to cos theta, and cos 90 plus theta is equal to minus of sine theta. Now let's have look at some more formulae. For example, sine A plus B. So this is equal to sine A cos B plus cos A sine B. Now if I put minus here, sine A minus B, then formula gets converted into sine A cos B minus cos A sine B. Example is, suppose you have to find sine 135 degree. So you can write this is sine 90 plus 45. Now apply this formula. You can find sine A cos B. Here A is 90 degree, B is 45 degree. So sine A cos B plus cos A cos 90 sine B. So here sine 90 is 1, cos 45 is 1 by root 2 plus cos 90 is 0, and whatever comes in this bracket will be 0. So the final answer is 1 by root 2. So in this way you can use this formula. Next formula, cos A plus B. Cos, if I write cos A minus B, cos A minus B. So the formula is cos A cos B plus sine A sine B. If I put plus sign here, that is cos A plus B, the formula gets converted into cos A cos B minus sine A sine B. Hana, observe the difference in sine formula. If here it is plus, then in the between the terms there is also plus, and for minus here it is minus. But in cos there is reverse. If here you are writing the formula for cos of A minus B, then in between the terms there is plus sign. And if you write cos of A plus B, then in between the terms you have minus sign. Are you getting? Now tan A plus B. So its formula is tan A plus tan B by 1 minus tan A tan B. Now if you put minus sign here, that is tan of A minus B, then formula would be like tan A minus tan B and divided by 1 plus tan A tan B, isn't it? Then very important formula, sine square theta plus cos square theta is equal to 1. And one of the outcomes of this formula is cos theta is equal to root over 1 minus sine square theta, isn't it? Now sec square theta minus tan square theta is equal to 1. Cosec square theta minus cot squared theta is equal to 1. Sin 2 theta is equal to 2 sin theta cos theta. For example, if you wish to find sin 120, so this sin 120 can be written as sin 2 into 60. So 60 is theta. So sin 2 theta is given by 2 sin theta, that is 2 sin 60 cos 60. So sin 60 is root 3 by 2 and cos 60 is 1 by 2. This 2 gets cancelled and finally you will have root 3 by 2. Now the next formula is cos 2 theta. This is cos squared theta minus sin squared theta. So these are the basic formulae of trigonometry which are used in physics, isn't it? So you can have a screenshot. Now next we have a reduction formulae. So observe the examples I am giving you, and then we will be able to understand the procedure how to find the values of different angles, that is sine 270 degree, sine 300 degree, sine 315 degree, cos 315 degree, all different angles by using the method we are following. But keep patience. Once you came across or you will get through this 5 to 6 examples, you will get able to find this value. So I am trying to explain this formula with the use of different examples. So let us start. Hana. Let us suppose if I write sine let us suppose if I write sine, suppose 135 degree, sine 135 degree. So this sine 135 degree can be written as 90 into 1 plus 45 degree, isn't it? So the very first step is observe the angle, that is 135 degree, and this 135 degree angle lies in the second quadrant. Are you getting that? And in second quadrant, the value of sine is positive. Remember that trick, all school, S for school, S for sine. So whatever value comes, the value is in positive. I mean the value will be positive. So the very first step is observe the angle in which quadrant that angle lies and choose the sign accordingly. Then the second step is observe the multiple of 90. So this is odd multiple of 90, and 90 into 1 it means odd multiple. So whenever there is odd multiple, convert the sign into cos. And if there would be cos, then convert that cos into sine. Isn't it? So this is sine 90 into 1. 1 is odd. So convert this sine into cos. So here it will become cos. So this is covered, sine is covered, and the only thing which is left is 45 degree. So write cos 45. So the answer will be plus 1 by root 2, because 45 degree is a standard value we have to keep in mind. Suppose if I write sine 240 degree, sine 240 degree. So the very first step is split this 250 degree, Hana. So this can be written in terms of multiplier of 90, that 90 into 2 plus 60. 180 plus 60 is 240. So the very first step is, so this angle lies in third quadrant. In third quadrant, the value of sine will be negative, because in third quadrant only tan and cot are positive and rest all the angles are negative. Rest all the trigonometric ratios are negative. So here it is plus. The second thing is, this is even multiple, and a multiplier is 2, that is even multiple comes. So whenever even multiple comes, this sine or cos or whatever the ratio, it will remain as it is, isn't it? There will be no change. For example, here it is sine, this is even multiple 2, so here I write sine. and then 60 is left, so this is 60, so this will be root 3 by 2. Acha, and one thing here, here the sign will be negative, isn't it? Why? Because angle lies in the third quadrant, and in third quadrant only tan and cot are positive, remaining all the angles are ratios are negative, so sign will also be negative. Now suppose if I write sine 300 degree, sine 300 degrees, so this can be written as sine 90 into 3 plus 30. 93 is a 270 plus 30 is 300. So the very first step is the angle lies in the fourth quadrant because the angle is greater than 270 degree. The first thing. So in fourth quadrant, cos is positive and remaining all other trigonometric ratios are negative. So here it is sine, then the value will be negative. So the value will be negative. Second thing, this is the odd multiplier comes, that is 3 is odd number. So we convert the sign into cos. So this will be cos. And after that 30 is left. So minus cos 30, that is minus root 3 by 2. So in this way we have to convert. That's why this is known as reduction formula. Now let's have examples corresponding to cos. Hana. Suppose if I write cos 120. So the very first step, this can be written as cos 90 into 1 plus 30. So very first step is 120 degree lies in the second quadrant, and in second quadrant sine ratio is positive and remaining all other ratios are negative. So cos will be negative in second quadrant, so put negative sign here. Then here it is odd multiplier of 90. It means that cos gets converted into sine. Like sine converted into cos whenever there is odd multiplier. In the same way, cos converted into sine whenever there is odd multiplier. And you are left with sine 30. So this will be minus 1 by 2. Now suppose if I write cos 225 degree. So this can be written as cos 90 into 2 plus 45. So the step number 1, 225 degree lies in the third quadrant because it is greater than 180 degree. In third quadrant, tan is positive, but here it is cos, so it will be negative, so put negative sign here. Now here it is even multiplier, so the ratio will remain as it is, same, that is cos, isn't it? And you will left with 45 degree. So the answer is minus 1 by root 2. Are you getting? Now if I write cos 315 degree, so this can be written as cos 90 into 3 plus 45 degree. So the very first step, 315 is in fourth quadrant. So in fourth quadrant cos is positive, so put positive sign here. Then here it is odd multiplier. So since it is odd multiplier of 90, then cos gets converted into sine, and then you are left with 45. So this will be 45. So the answer is plus 1 by root 2. So in this way you can have many more formulae. You can also find, for example, tan 135 degree. So what is tan? This can be written as 90 into 1 plus 45. So since 135 degree lies in the second quadrant because the angle is less than 90 degree but less than, angle is greater than 90 degree but less than 180 degree. In second quadrant the tan is negative because tan is positive in third quadrant and first quadrant. So here put negative sign. Now it is odd multiplier of tan. So this will be cot, isn't it? And for this will be 45. And cot 45 is 1. So this will be minus 1. So in this way you can find many more different values. You can have many, you can practice by your own by taking different angles. And to check you can have calci and apply this procedure. And it will be very easy and it will be take within 5 to 10 seconds you will be able to find once you have practice. Isn't it? So these are the reduction formulae, dear students. Next, inverse trigonometric function. So let us first understand that what is inverse trigonometric function. So first of all, if I write sine 30 is equal to 1 by 2, then this 30 degree can be written as sine inverse 1 by 2. This 30 can be written as sine inverse 1 by 2. Now suppose if I write sine 150 degree. Now what is sine 150 degree? Apply the same rule just we have followed few minutes back, that this can be written as 90 into 1 plus 60. So this is the angle is in second quadrant. In second quadrant the sign is, the value is positive, sine theta is positive, and this is odd multiplier of 90, then sine gets converted into cos and you will left with 60. So this is cos 60 and this is having value that is 1 by 2. So sine 150 is also having value equal to 1 by 2. So here you can write 150 degree is equal to sine inverse 1 by 2. So what conclusion we make? We make that if I write sine inverse 1 by 2, then this is equal to, we are having two values. The angle theta may be 30 degree and the angle theta may be 150 degree, because sine 30 is also 1 by 2 and sine 150 is also 1 by 2. So this is known as inverse function, inverse trigonometric function, that is sine inverse. It is read as sine inverse 1 by 2 is equal to 30 degree, sine inverse 1 by 2 is equal to 150 degree. So there are maximum two, there are in between 0 degree and 360 degree, there are maximum two values of any angle which corresponds to same value. There are two angles, maximum there are two angles that corresponds to same values. We have to find that angle. So again I am saying, then don't learn the rule, just observe the examples. We will have at least 5 to 6 examples, and if you observe these examples carefully, then this procedure will be crystal clear to you. It's very easy. You have to follow certain rules. That's all. Suppose if I write sine inverse 1 by 2. If I write sine inverse, 1 by 2, just we have seen, let us take different. Let us take different value. Sine inverse root 3 by 2. So observe step number 1. And what is step number 1, dear students? Let observe this value. So this value is plus. Root 3 by 2 is plus. And in which quadrants the value of sine is positive? For example, what I am saying, observe carefully, that if I write sine inverse root 3 by 2, angle comes, it can be written as sine theta is equal to root 3 by 2. This is the meaning of this expression. No? If sine theta is equal to root 3 by 2, it means that theta is equal to sine inverse root 3 by 2. Just we have seen that sine 30 is 1 by 2, then 30 is nothing but sine inverse 1 by 2. Similarly, we are applying this rule here. So sine theta, this value of sine theta is having positive value. And since this is having positive value, it means that the angle theta must lie in which quadrants? Either in first quadrant or in second quadrant. Are you getting? Because only in first quadrant and second quadrant, the value of sine theta is positive. So the very first step is choose the quadrants. The very first step is, if you wish to write, then you can write choose the quadrants. There are two quadrants. The second step is out of the standard values, when the sine theta, for which angle theta, sine theta becomes root 3 by 2, that is 60 degree. That is 60 degree. So the second step is, what is the second step? Then for the, what is second step? Then out of the standard values of theta, this root 3 by 2 corresponds to which angle? That corresponds to 60 degree. isn't it? So we have selected the angle out of the standard values. Now, the third step is, what is third step? That now, before going to the third step, let us have a look at this. If the line comes in first quadrant and fourth quadrant, then take the angle by the with reference to positive x-axis in this step. And what I'm saying, I'm repeating it. If this line lies in first quadrant or fourth quadrant, then take the angle with respect to positive x-axis. If this line lies in second and third quadrant, then take the angle with respect to negative x-axis. Are you getting? Now what I am saying, you select the angle that is 60 degree. Now take the angle of this line from this positive x-axis as 60 degree and take angle of this line from negative x-axis as 60 degree. So this is step number 2. What is step number 1? Choose the quadrants. What is step 2? Mark the angles from positive x-axis and negative x-axis, isn't it? If the line lies in the first and the fourth quadrant, then take the angle from positive x-axis. If the line lies in the second and third quadrant, then take the angle from the negative x-axis. And the final step, which is very important, final step, the final angle will be taken only from this reference line, that is positive x-axis. In intermediate step, that is step number 2, take the angles from both the axes. But in final step, where we are finding the final values of the angle, take the angles only from this reference line, that is from positive x-axis. So if this angle, the line of this angle from reference line is 60 degree, so the first angle is 60 degree, and the second is the angle of this line. So this is 60, and this will be 30, and this will be 90. So this whole angle is 90 plus 30 is 120 degree, because we have to take the angle of this line from positive x-axis, that is reference line, in the final step. So two angles are theta is equal to 60 degree and 120 degree. It means that sine 60 is root 3 by 2 and sine 120 is root 3 by 2. I am saying keep patience. Hana? Suppose there are 3 steps. If you have confidence in the first step, then it's okay. If you have understood all the steps, then it's also okay. And if you are not able to understand the steps, then don't panic. Don't be panic, dear students. Keep patience. In the upcoming 4 to 5 examples, we will be able to understand the whole steps very easily. Suppose if I write sine inverse minus 1 by 2 is equal to theta. We have to find the value of theta. So what we do? Just draw this quadrant. So the step number 1, choose the quadrants. Since this value is negative, so sine is having negative value in third and fourth quadrant. So the two lines turn or lies in either in the third quadrant or in the fourth quadrant. Because in the first and second quadrant the value of sine is positive, in third and fourth quadrant the value of sine is negative. Now the second step is 1 by 2. We have covered the minus. Now let us have look at 1 by 2. So out of the standard values, sine theta is equal to 1 by 2 for angle 30 degree. For angle 30 degree. So 30 degree. So what is step number 2? We mark the angles of these two lines from the two axes, that is positive x-axis and negative x-axis. So here this angle is 30 degree and this angle is 30 degree. So since this line is third quadrant, so we take its angle from this negative x-axis. This line is fourth quadrant, so we take its angle from positive x-axis. This is the step number 2. But what we do in the final step? In the final step, we take the angle from positive x-axis only, that is reference line. This is the final because we are in step number 3 and we are going to find the result, final angle. So since this is 90, 180 plus 30, so this is 210 degree. Second, 90, 180, 270, and this will be 60. So 180, 270. 270 plus 60 is 330 degree. Because this is 13 and this will be 16. So the value of angle of this line with reference to reference line is 330 degree. So angle is given by either the angle is 210 degree or 330 degree. So this is the procedure. Suppose we need to find cos of minus 1 by 2. So the very first step is observe the sign negative. So cos theta is negative in second quadrant and third quadrant. So the line lies in the second quadrant and third quadrant. Since the two lines are in second and third quadrant, so angle we take in the second step will be from negative x-axis only, isn't it? Now out of the standard values, cos theta is 1 by 2 for 60 degree. Cos 60 is 1 by 2. So angle is 60 degree. So in step number 2, we take the angles of this line from negative axis because the two lines are in second and third quadrant. So step number 2 completed. Final step, that is step number 3, we take the angles of this line from the positive x-axis, that is from the reference line. So if this is 60, then this will be 30 degree. So the whole angle, that is the angle of this green line from reference line, this positive x-axis is given by, this is 90 plus 30, and 90 plus 30 is 120 degree. Now angle of this line with respect to this reference line is, so this is 90, 180 plus 60. So this is 240 degree. So this will be cos inverse minus 1 by 2 is equal to, either it may have value 120 degree or 240 degree. So in this way, you can have many more examples, dear students. If you find difficulty in this method, just comment in comment box. I will take some more examples and make a separate video lecture, particularly on this topic. Let us switch to the next topic. Now graph. Since before proceeding to graph, I would like to draw your attention towards an important point. That point number 1. The value of sine theta is always greater than or equal to 0. Is always greater than or equal to minus 1 or less than or equal to plus 1. It means that the value of sine theta dances in between minus 1 and plus 1. The value of sine theta will never be greater than plus 1 and never less than minus 1. Similarly, cos theta, it will always having value in between minus 1 and plus 1. But if you talk about tan theta, then it is in between minus infinity to plus infinity. Now, second important point, always remember sine theta is nearly equal to theta, but theta in radian for small angles. For small angles. That is for angle less than 25 degree or less than 30 degree, that is pi by 6 radian. The value of sine theta is approximately equal to theta. But in case of cos theta, this value is equal to 1 for very small angle. Because as theta approaches to 0, the value of cos theta approaches to 1. Isn't it? Now, come to the graph. So this is the graph of sine theta. Here, the value of theta is pi by 2 radian, that is 90 degree. And the value of y is 1. So here, what is y-axis representing? Y-axis is representing sine x. And what is x? X is nothing but angle theta. So sine 1, here sine 180 So this is the origin. This is origin, that is 0. So here it is sine 180. Observe pi radian sine 180. The value of sine 180 is 0. What is the value of sine 270? That is 3 pi by 2. So sine 270 is again minus 1. So this is the value of minus 1. So here sine 270 is minus 1. Now, to this value, and you observe carefully, the value of sine theta never goes beyond plus 1 and never goes beyond minus 1. It will have its value in between plus 1 and minus 1, and this curve is known as sinusoidal curve. Sinusoidal curve. This curve is very, very, very important, because you must remember in class 12 in the chapter alternating current, the alternating current, alternating voltage are represented by this sinusoidal curve. In electromagnetic waves, the wave phenomena of light is represented by this sinusoidal curve. In the chapter oscillation and waves, that is class 11, last two chapters, oscillation and waves, there we have the wave pattern. That wave pattern is also represented by this sinusoidal curve. The simple harmonic motion, that motion is being represented by this sinusoidal curve. So any student which has got difficulty in this curve also face difficulties in these chapters, which I just mentioned. So this is known as sinusoidal curve, and this cos curve is also known as sinusoidal curve. The basic difference in sine curve and cos curve is that sine 0 is 0, so sine curve starts from the origin when angle is 0. But in case of cos, when angle is 0, so since cos 0 is 1, so this curve starts from plus 1, and in this way the graph goes like this, isn't it? So here you have the values, that is, observe carefully, cos pi is given by, that is, cos pi is minus 1. So cos 180, that is, cos pi is minus 1, isn't it? And there are many more values. Again, here this is cos 360 is 0. This is 3 pi by 2, that is, cos 270 is 0. So cos 270, that is 3 pi by 2 is 0. In this way you can find many values, and this is the graph. So next is sine and cosine rule. So what is sine rule? Sine rule is very simple, dear students. Suppose if I take this angle as alpha, this is beta, and this is gamma. Opposite to angle alpha, the side is A. Opposite to beta, the side is B. And opposite to gamma, the side is C. So the sine rule says that sine alpha by A, or A by sine alpha, is equal to sine beta by B is equal to sine gamma by C. So this is the sine rule. And cos rule is equal to C square is equal to A square plus B square minus 2AB cos gamma. So this is rarely used. This formula is important, used in Lami's theorem as well.